Molecular hydrogen, the clean fuel of the future. Molecular hydrogen, the clean fuel of the future. The world's dependence on fossil fuels like petroleum and coal has led to significant environmental problems, including air pollution, greenhouse gas emissions, and climate change. As a result, scientists and engineers are now turning to alternative forms of energy production that can offer a cleaner, more sustainable way forward. Molecular hydrogen is one such solution that is gaining traction as a clean fuel source of the future. Molecular hydrogen, H2, is the smallest and most abundant molecule in the universe. It is made up of two hydrogen atoms covalently bonded together. Despite its simplicity, molecular hydrogen has array of unique properties that make it an ideal candidate for a clean fuel. One of the most appealing characteristics of molecular hydrogen is that it is a clean burning fuel. When it is burned, it produces only water and no harmful pollutants such as carbon dioxide, carbon monoxide, or hydrocarbons that contribute to climate change and acid rain. This makes molecular hydrogen an attractive alternative to fossil fuels in areas where air pollution is a major problem. Another advantage of molecular hydrogen is that it is highly efficient. When it is used as a fuel in a fuel cell, it can convert more than 80% of the energy it contains into useful work. This is significantly more efficient than internal combustion engines, which typically achieve around 25% efficiency. The high efficiency of molecular hydrogen makes it an attractive option for powering vehicles, homes, and other applications. Molecular hydrogen is also abundant and easily accessible. It can be produced using a variety of methods, including electrolysis of water, steam methane reformation, and biological processes like fermentation. While there are environmental concerns associated with some of these methods, they are generally considered to be environmentally friendly and sustainable. Moreover, hydrogen is readily available as a byproduct of chemical processes in industrial settings. This makes it possible to produce molecular hydrogen on a large scale using existing infrastructure and technology. Despite these advantages, there are also several challenges associated with the widespread adoption of molecular hydrogen as a clean fuel source. One of the most significant challenges is related to storage and transport. Molecular hydrogen is a gas at room temperature and requires a high level of compression or liquefaction to transport it effectively. Moreover, molecular hydrogen has a low energy density compared to other fuels, which means that it takes up more space to contain the same amount of energy. Another challenge associated with molecular hydrogen is safety. While molecular hydrogen is non-toxic and non-flammable on its own, it can become explosive when mixed with air in certain concentrations. This means that special safety protocols must be in place to prevent accidents and leaks. Despite these challenges, scientists and researchers are making significant strides in the development of molecular hydrogen as a clean fuel source. One area of focus is the development of better methods for storing and transporting molecular hydrogen. This includes research into new materials for hydrogen storage, such as metal hydrides and carbon nanotubes, and new methods for liquefaction and compression. Another area of research is the development of advanced fuel cell technologies. In addition to these technological advances, there is also a growing recognition of the need for policy and regulatory support for the adoption of molecular hydrogen as a clean fuel source. The potential applications of molecular hydrogen as a clean fuel source are numerous and varied. One of the most promising areas is transportation. Molecular hydrogen-powered vehicles are already in use in some parts of the world, and more are likely to be developed as fuel cell technology continues to improve. Molecular hydrogen can also be used to power buses, trains, and other forms of public transportation. In addition to transportation, molecular hydrogen can be used to generate electricity and heat for homes and businesses. Fuel cells can be used to generate electricity for buildings, reducing reliance on grid power and lowering carbon emissions. Molecular hydrogen can also be burned in boilers to generate heat for space and water heating. Molecular hydrogen can also be used in industrial processes, such as steel production and chemical manufacturing. In these applications, hydrogen is typically used as a reducing agent, replacing more polluting substances like coal and coke. Researchers and scientists around the world are working to unlock the full potential of molecular hydrogen as a clean fuel source. One exciting development is the use of hydrogen fuel cells in aerospace applications. Fuel cells are ideal for use in space because they provide a reliable and efficient source of power without producing harmful byproducts. In fact, NASA has been using hydrogen fuel cells in its spacecraft since the 1960s. Molecular hydrogen is also being explored as a potential solution to energy storage. One of the key challenges with renewable energy sources like solar and wind is that they are intermittent. Energy storage technologies are needed to capture and store excess energy when it is available for use during times when the sun isn't shining or the wind isn't blowing. Molecular hydrogen is one of the most promising solutions to this problem. One approach to using molecular hydrogen for energy storage is to combine it with carbon dioxide to produce methane gas. Synthetic methane can then be stored or transported via existing natural gas pipelines and used as fuel for power plants and other applications. This process, known as power to gas, is already being used in some parts of Europe and Asia and is seen as a key part of the transit to a low-carbon energy future. In addition to power generation, molecular hydrogen is being explored for use in a wide range of other applications, such as cooling and refrigeration. Hydrogen-based refrigeration systems are more efficient and environmentally friendly than traditional refrigeration systems, which rely on potent greenhouse gases like hydrofluorocarbons. Other potential applications include hydrogen fuel cells or portable electronic devices like laptops and smartphones, and even for remote power supplies in off-grid locations. Another exciting development in the field of molecular hydrogen is its